Welcome back to Ox Tools. I'm Tom. Tonight we got a short video, and what I want to show in this video is some guys have been asking about tool bit honing, in particular for the lathe, and how tool bits are sharpened, how they're honed by hand, and how they're tuned up and ground. So there's a lot of videos on the web about grinding tool bits, so I guess what I want to focus on is some of the subtleties of tuning those bits up and making them perform the way you want to make them perform. So we're going to do two tool bits and two completely different types of tool bits, different requirements, although they have some similarities also. And really we're going to focus on hand ground stuff here, as opposed to inserted things and that kind of stuff. Generally you don't monkey with inserted geometry, although sometimes you have to relieve them, but that's outside the scope of this particular video. So we're going to show a classic turning tool bit, lead angle turning tool bit, and we'll also do a fly cutter bit for the mill. So you get one of each. The techniques are kind of the same across the board for tool bits. Obviously the geometries are different, but let's zoom in and look at a couple of things that we're going to grind. Okay. All right. So here we got a couple of blanks, and I went through my junky blanks and found a couple that I didn't like the looks of anymore, and that I could easily convert into these, for example. So I have two here. One's a little shorter than the other. This is going to be our fly cutter bit for this guy here, and the reason is I don't want a whole bunch of stick out like that. What I want is a nice tight little package like that for the fly cutter. So this will be our fly cutter bit, and these are just high-speed blanks here. You know, this one that's a factory in there, but there's something that got blown away doing some job there, so who knows what happened there. Anyway, so we're going to do a fly cutter bit, and then a classic lead angle turning bit. So what that looks like, the geometry of that is it'll have a slight lead angle like this, and then a back angle, and then we'll add a chip breaker to it. This one is the fly cutter. It's almost square on the end, and that will also have a chip breaker too. But what I want to show too is the effects of the as we progress through the tool and the development of the tool. So we'll probably do some test cuts as we start to get the geometry, and then you can see what effects some of the changes have on the cutting action. Okay. So anyway, we'll go over to the grinder and do a little grinding. So I just wanted to briefly show my Toolbit drawer, my rollaway, and so after many years of grinding tools, this is kind of what you end up with. You end up with a huge selection of different tool bits, and you know, one of the beauties of hand grinding your own geometries for different things is that the sky's the limit. There are so many possibilities, and in fact, you would be hard pressed to do every job with you know, kind of standard inserted tools. They just don't have everything that's needed, and or do you care to purchase everything that's needed? So you know, sometimes you have a one-off job, and you really need to you know, grind some kind of wacky geometry for something, but that's the beauty of high speed and being able to hand grind your own tools, is that, you know, you can create a wacky tobacky tool like that or some little tiny boring bar like that, and you know, it's a few minutes on the grinder and you're off and running. So you don't have to wait for something to show up in the mail and or what, and you can touch these up, and if you break them you can make another one, right? So you know, some of these, this is a good example here. You know, that's a $30 insert on there, right? So you don't buy 10 of them at a time, right? You buy like 2 or 1, you know, and it's got 3 edges on it. But that's for special stuff. And so, you know, hand grinding is still valid. And for the home guys and small shops, it's really, you know, kind of bread and butter stuff, and quite useful. So anyway, I just wanted to show you a collection, and you know, these get repurposed all the time. You know, the ones I just showed you, we pulled out of here, and you know, they're getting remade into a demonstration piece. And this is a tool we made a couple weeks ago there, I think. So anyway, all right, let's get going here. Okay, that looks pretty good. That looks pretty good. And this is just a deglazer here. pretty good. One more. Okay, that'll cut real nice actually. Now what we're going to do is we're going to do a little test without doing anything to the edges. Just cut the way it is. And we'll make a test, and then we'll hone these edges, and then we'll do another cutting test. Okay, so here's our test piece. And this is 1.5 inch aluminum and 50 millimeter aluminum, and what I've done with the tool bit, so what I've left this lead angle here, so we can't turn a square shoulder, but that's okay for our test. I've ground a shallow enough lead angle on it that I could actually rotate the bit so I could cut a square shoulder with this same bit. And then the front angle here is less than 90. So what that means is I still have clearance on this face if I want to cut a square shoulder with this. So that's why I chose that particular angle. You know, they show a lot of angles in the books, and the bottom line is there's a wide range of angles that will work. It's not an exact science. So there's some optimal things, and theoretical optimals, and then there's stuff that works. And so lots of things work. So this is how I grind a lead angle tool so that I can use it for a square shoulder if I want, or I can face with it. But for our testing, it's easier to repeatably put it in the tool holder square for each part of our test. So we're just going to use the lead angle here. Now this is untouched off of the grinder. In fact, it's still got fuzz on it from the grinder. So that's raw right off the bench grinder. So we're going to run at 550 RPM, and I'm going to use a fairly coarse feed rate. We'll try 2. 15 thousandths per rev, and then about 8 thousandths per rev, which is about 0.4 millimeter per revolution in 0.2 revolution or 0.2 millimeter per revolution feed rate. And so let's go ahead and give it a try and see how it performs. Okay, so there's my touch off, and I'm going to take 1 millimeter depth of cut, about 40 thousandths, or I should say 40 thousandths on the diameter. All right. Okay. So let me kick this thing into Okay, so I shifted the camera into macro mode, and you can see this is a pretty crappy finish here. Okay, so let's slow the feed rate down and see if that helps. And let's go down to half of our feed rate, which is about 8 thousandths per rev, or 0.2 millimeter per rev. And we'll do another 40 thousandths on the diameter. Okay, so still got a crappy finish. It's cutting nice and free. It would be fine for a roughing tool, but we really want to make a nice finish on that. So you saw the chips coming off. They weren't too bad. They were curling off and coming off this way, which was pretty good. Later on we'll put a chip breaker in this. We're going to keep modifying this tool. Okay, so here's our Toolbit that we just tested. And you can get a better look at it. So this is looking down at the top like you'd see in the lathe. Also, just for reference, this is a right-handed cutting tool, even though our primary edge is on the left. So the way I remember that is, if I'm looking at the Toolbit, like the workpiece, if I was the workpiece, the cutting edge is on the right-hand side. So that's how I remember that. So when you look at the tool straight on, the cutting edge, which side is it on? So this is a right-handed tool. Okay, so we just have it's just a Norton multi-stone here, you know, Joe average stone, nothing fancy here. So what we're going to do is we're just going to hone this tool a little bit and see if we can make an improvement. So what I'm doing here is I'm laying it down on this first edge here, and I'm finding where it wants to lay here, just pushing on it, and then I'm just gonna take a couple of swipes, and I'm pushing down pretty good. I don't know, can you see that? Yeah, there we go. All right. And you see you can probably see a little edge right there where my fingernail is, where I'm touching up that edge. Let's see if I can do it so you can see. It's a little awkward with the camera here, so bear with me. And I can feel it on the stone. It's getting better. Let's see. You see that edge there? That's what we're doing there with that honing. I don't need to do the whole face. It's just a little bit of the cutting edge that we need to deal with. So I get out near the tip there still. Alright, it's looking pretty good. Okay, I like that. And you can see the little flat. And that's nice and smooth. Okay, so now I'm going to do the same thing on the end here. The end cutting edge. And you see how it plowed that material up? That's good. That means I was right on the spot that I wanted to be on.
Okay, and you can see that. Okay, so that will make a big improvement, but there's one thing left to do here. I could do this top edge also, but we're going to grind a chip breaker in that in a minute. So this edge is really important too. In fact, this is probably the most important edge here, this little corner here. So what we want to do is we want to just put a small radius or flat there that's nice and smooth. So the way I do that is I lay it down on that edge, and then with a rolling action I kind of wipe that on the stone. I'm starting on the primary edge here. This is the edge that sees the material first, and then I'm rolling onto the clearance edge, if that makes sense. Okay, so actually that looks pretty good. Let's see if we can see that. You can just see it because it catches the light differently. That's what I'm looking for right there. Oop. Let's get something pointier there, Tom. So that's what I'm looking for, this little flat edge there. So now with that couple of strokes on the stone, let's go back and test that same tool with the same feed rates, okay? Okay, so we got the honed tool bit back in there. So let's give it a try. Same thing, 40 thousandths depth of cut. Let me touch off. And you can see the difference immediately. Okay, so this is still a fairly fast feed. Oh, this is we're at 8 thousandths per rev, or 0.2 millimeters per rev. Oop, my hand's dirtying it up. But you can immediately see the finish improved radically. It's not a torn edge. It's smooth to the touch. It is a little bit of a record player, but you can hear that, and that's because of the feed rate. So let's increase the feed rate again, and we'll try it back at the higher feed rate. Okay, there's 40 thousandths again, or 1 millimeter. So it's much smoother and it's brighter, but it's got the record player finish, and mainly that's from the feed rate. So let's do a much slower feed rate. Let's try that. Let's see, that is B, C, G. So that's too slow. BCF. Okay, let's try that. So this will be half of that, 4 thousandths per rev, or 1/10 of a millimeter per rev. Excuse me. 20, 30, 40. With our 40 thousandths again. And that's a pretty good finish there, but we can do better. So let's take our tool out again, and we're going to re-hone it, and try that one more time. Okay, so I went back and I honed that a little more. So I increased the size of the radius just slightly, and I lapped it and honed it a little more using the same technique, and I also did the top surface there too. Okay, so let's try that. I'll put it back in the tool holder and we'll try that. Okay, so here we go. So this is 4 thousandths per rev, or a tenth of a millimeter per rev, and 550 RPM, 1 millimeter or 40 thousandths on the diameter. Okay, that's a pretty nice finish. So that's a pretty nice finish. In fact, my dirty fingers are are messing it up. And I don't have a red. Oh, there's one. Okay, so anyway, that's a pretty good functioning tool bit there. Let's improve it just a little more. We're going to add a chip breaker to that. Okay, so we're going to grind the chip breaker. Now I'm going to go on this side here, and the reason I'm going on this side is you can see this has a bunch of grooves in it, and it's from sharpening tungstens on there. But one neat thing that happens when you do that is you end up with a little narrow section here that actually makes for grinding chip breakers really easily. Normally you would want a grinding wheel with a very sharp corner on it to put a chip breaker on this. And what we're going to do is we're going to go right in this area here, and we're going to create a chip breaker along there. Okay, and so what I'm going to do is I'm going to come in like this, and you're not going to be able to see it very well. I can barely see it myself, and I'm doing the work. You got to work real slowly and at a vertical angle, and I'll just let the camera run, and hopefully you can get the idea. So. Okay, so I've started it there, and you can kind of see it. What I'm trying to do is get a groove started so that I don't jump out of it, and then I'll work it over towards the leading edge there. You can also do them uphill like this, but I'm kind of a downhill guy, so whatever that means. Okay, so we've got our chip breaker, and I just touched it up on the stone to hone it a little bit after grinding the chip breaker. Just a couple of strops, as I was showing earlier. So we're 4 thousandths per rev, 1/10 of a millimeter, 550 RPM. And we'll do our 40 thousandths, 10, 20, 30, 40. Let's see what happens. Okay, so you can see the chip is going into the chip breaker, but it's not breaking either. So that's not what we want. So we're at a very fine feed rate, so what we're going to do is we're going to increase the feed rate so that we're engaging more material, and let's see if the chip breaker performs then. Okay. I think that's it. Yeah. So this is our 0.4 millimeters per rev. Or 15 thousandths per rev. Let's try that. See how that behaves. It's a little better. Okay, they're breaking. But they're breaking kind of long. Probably needs a tighter curl. Let's try a larger depth of cut. So 1.5 millimeter. Okay, they're breaking, but they're still long. Also, my diameter is getting a little smaller too. Well, that's pretty good for 15 thousandths per rev. So, but the chips are a little long. 6061, which is what this alloy is. You know, it's not real cooperative with chip breaking, but you can get it to break. Oh, wait a sec. That wasn't 15 thousandths. Let's try. I'm sorry. That was 8 thousandths per rev. That was 8 thousandths per rev, not 15. I was wondering why the finish was so good. Let's try that. And our 40 thousandths depth of cut. There you go. And now the chips are breaking, which is okay, which is good for roughing. So by increasing the feed rate, we can actually make good chips like that. Okay, small curls, and you know it's not a great finish, although for roughing it's good. It's cutting freely. The chips are breaking, so chip control is good, and we're working. So you would probably, if you were doing a lot of work, you might have a roughing and a finishing bit. Let's try a bigger depth of cut here. See what we get. So from this demonstration, you can see that all of these factors are interconnected, and so a particular geometry at one feed rate might not perform at another feed rate or another depth of cut. So don't be discouraged if your tools don't produce perfect chips at every feed rate and every depth of cut. what I'm demonstrating here too is it's dependent on the depth of cut and the feed rate. So here we have perfect chips at I don't know, 60 thousandths, a millimeter and a half on the diameter, and 15 thousandths per, God dang it, 15 thousandths per rev. The chips are pretty good. But when we slow it down, the exact same geometry does not produce a good chip. Okay, so that's the lesson here. Let's go back to our slow feed rate again. Okay, now we're making long stringy chips. Although they're thin, so the control of them is not too bad, but you cut a lot of that and pretty soon you got a kind of a rat's nest there. Okay.